Alright guys, welcome back to Algos Made Simple. Got a hard Leetcode problem on here today, but I think it's one that with this thought process we're going to go over in the video becomes not so difficult at all. And something that you can, while you hope not to draw this question in an interview setting, it'll be something that doesn't terrify you and doesn't ruin your whole interview experience, especially if you go through this problem a couple times with a thought process in mind and really making sure you have these core concepts and the core thought process for this problem completely down. So with that being said, let's dive into it. It's Leetcode 76, minimum window substring. Given two strings S and T of lengths M and N respectively, return the minimum window substring of S such that every character in T, including duplicates, is included in the window. If there is no such substring, return the empty string. The test cases will be generated such that the answer is unique. A substring is a contiguous sequence of characters within the string. So I let the interviewer know, okay, I understand I'm getting a string S and a string T, and I want to return the shortest set of characters that will have the shortest set of contiguous characters that will have every character in T, including duplicates. So every character in T will be represented in this substring of S, and I want to do it with the minimum string possible. And if there is an answer, there's only going to be one answer. So I don't have to worry about returning multiple substrings. I have to return one substring. I just got to find what that smallest minimum substring is. So I understand conceptually what's being asked of me. So how would we do something like this? Okay, let's look at this example here. We've got S equals a bunch of jumbled up letters, and we're trying to find A, B, C in it. So the easiest thing to think of, okay, if I was just doing this on a piece of paper, just minding my own business, it was just printed out, I would say, okay, I've got an A here. All right, I'm going over. Got a B here, that's in T, cool. Going over. All right, I've got a C. All right, I've done it. I've got all the letters. That substring is 6 characters or so, whatever. So my current best I've done is 6. So what would I do at this point? Okay, I could start adding more letters, but I know that I've already hit the amount that I need, so I don't need to add more letters to the right because that's just going to have me go up, up, and up. Well, I could go ahead and move over here to this O, but then I'm leaving all these letters that I've already found, and I'm handing them out to dry. It makes no sense because there might be a better substring that starts at this B right here, and I would be missing out on that. So what I need to do, once I've found that substring, I've found that the number of characters that I need, okay, can I shave a character off of the left? Because I'm started at the left. This could have been a Z. It didn't have to be a part of T. I would have still started here. Can I shave a character off of the left and still hit my requirements? So I would try to shave this character off, and I would say, okay, I've shaved this character off. Do I still meet the requirements? So I'd have D through C here. Do I still meet the requirements? No, I no longer meet the requirements. So at that point, then I would start adding to the right again until I met the requirements again, which would be here at this A. Then I would see how much I could chop off of the left again to be able to meet those requirements. So I would come here from DOB all the way to this A. And I'd say I've hit it again. That's lower my 6. Can I chop letters off to meet the requirement? Yeah, I can chop off this D and O, okay, and I get here, so now I've got, I'm still not less than 6, but I'm less than what I was, so I've got B, E, C, D, E, I think it was at this A right here or whatever. So can I chop off this B? I only need one of them, so yeah, I can chop off the B. Can I chop off the E? Yeah, I can chop off the E. So then I'm at here C, O, D, E, B, A, I'm getting closer. I've got all the letters there. I chop off the C, and now I'm missing a C. I'm at an O, D, E, B, A, N. So I'm going to add this in. I'm going to add this C. I've met the requirements again, and then I'll come here and start chopping off this O and this D and this E, and then before you know it, I'm left this B, A, N, C, this bank. So that might have been kind of confusing me going through it that way, but basically the concept is I'm starting here with the first letter, and I'm going to be utilizing a sliding window. So I have my left pointer, and then I have my right pointer, and I'm going as long as I need to go to find the characters in T till I meet the requirements. Then once I meet it, I'm going to see what can I get away with. How many characters can I shave off and still meet those requirements? Because I'm trying to have the minimum. I want to have the minimum amount of characters to still meet those requirements. So I'll shave from the left until I don't meet those requirements anymore. And at every step of the way, while I'm still meeting those requirements, I'll log the resolution. And if it beats the current resolution, it'll be replaced, etc., etc. And I'm going to add to the right when I don't meet the resolution anymore. Once I meet the resolution again, we'll carve from the left. So basically, the game plan is something like this: a sliding window where I'll move the right pointer, so add characters, until requirements are met. Once requirements are met, I'll shave or cut, however you want to say, I'll shave off from the left. So I'll move the left pointer, reducing characters until requirements are no longer met. And so at that point, when it's no longer met anymore, as long as I still have characters in the string, then I'll come back up here and I'll start doing the right again until I get to the point where I can start shaving from the left again. And it'll just be this cycle where I'll keep going, keep going, keep going. So that's great. We understand conceptually what we're wanting to do here, and that all makes sense. And we're going to have a resolution, and we're going to be keeping track of the resolution's length. That way we know if we beat the resolution or not, because the resolution we have to actually return the letter, so it's going to be 2 points. Like it's going to be our left and right pointer basically. But we have to see if we're beating this length. So that's great. We're on track there. How in the world are we going to look and see if we have these characters or not? If we have the if when we get to a character on the right, if it meets the requirements or helps us meet that requirement, or gets us, if we're still not at the requirement, etc., etc., how can we track that? Well, we need to use 2 hash maps, a count T hash map, so everything that's in T will have that log. So if there's 3 A's, we'll have A:3. We'll have one. There's 3 of them. If there's, all the way to 26 letters, there's a Z, we'll have that. We'll know that kind of thing. And then we're going to have our window, which will be consistently updated. And our window, each time we go to a letter on the right, and each time we go to the letter on the right, we will add that to that index if it's already there, or we'll start a new index for it and say, okay, we have 1 Z. We don't know if that Z helps out. We don't know if it's in count T. We're going to check for that, but we're just going to keep adding it to our window. And then once we start doing the left, taking it off, that's where we'll be removing these character values at that index from the window. And we'll compare, and we'll say what we need to have, because we don't want to have to, because what you could do, okay, you've got your count T and you got your window. We could go through every single letter, all 26 of them, every single time that we added a right and every single time that we took away from the left. We'd go through all 26 characters and say, okay, we need 2 A's, how many do we have? Okay, we've got 2 A's, great. We need 8 B's, how many B's do we have? We've got 8. We need 2 C's, how many do we have? We got 1. Okay, we're not great. We'd have to go through potentially 26 letters every single time. We don't want to do that. So what we're going to have is a have variable. So what we do have, what we've accomplished, which will start off at 0, we'll have nothing to start, and a need variable. The need variable is going to be the length of count T. And that's just going to say how many letters, how many requirements there are. It's not going to necessarily tell us how many of each letter there are. We'll still have to look and check that out. But it's going to tell us, hey, there's 10 letters that you have to account for and make sure you have the right amount of. And we'll update that have to say, okay, well, we've got 5 of them. We've got 7 of them. We've got all 10 of them. Let's start logging resolutions. So aside from that, of course, we're making that have go up, and we're making it down on the left if as the requirements are met or become unmet. So I think we've got a pretty good basis here. Let's go ahead and kind of dive right into the code and see if that explains it and clears this one up even better. So again, our game plan is a sliding window and we're going to use the right going out until we reach the requirements. Then once we reach the requirements, we're going to shave off, shave off, shave off while we still meet the requirements. If we ever don't meet the requirements again, we'll start adding these letters, adding these letters, adding these letters, and going from there. So we're adding, adding, adding until we meet requirements, shaving off, seeing what we can get away with. So then we're going to go here. Let's start at the code. We have got, what is this one even called? Minimum window substring. Minimum window substring. We're getting S and T. We're going to come here and we're going to say, the very first thing we need to find out is if T is just nothing. If there's nothing in T, then we got nothing to worry about. So if T equals an empty string, let's go ahead and just have a return down here of an empty string. Okay, so great. So the very first thing we need to do here, we've talked about it, we need to have two hash maps and go ahead and set them equal to empty hash maps so we can keep track of what letters are in T and what letters are in our window. So we don't know what letters are in our window yet. We don't want to even start adding those yet because we need something to compare it to. But we do know what letters are in T. So we're going to say for C, so for character in T, and we're going to go count T at this index character, at this index C, and it's going to be incremented by 1. So it's going to be 1 plus, and we're going to use the .get function, count T .get, and of course we're getting this character, but if this character is not in there yet, if we have nothing there, it's going to ruin the whole program if we just close off this parentheses. So we're going to have to say the default value is 0. So if there's nothing there, we're putting the first one there. So that's going to happen for everything in T. That's going to give us our whole T list of what we're trying to, what we have to meet. That's our requirements right here. So our requirements are coming from here. I can't even spell, but the requirements are coming from here. Okay, that's understandable. That's everybody should be tracking so far. This is not difficult at this point. So then we talked about having a have and a need variable because we don't want to go through every single letter in count T and compare it to the letters in count window every single time we pull a letter and see if we meet each requirement. Every time we take a letter off, go through all of them again each time, just saying, hey, do we still meet it? Do we still meet it? No, we just want to have something that's overall high level. Are we meeting it or not? So we're going to have a have variable and a need variable. The have variable is 0. We have nothing so far. Makes sense. The need variable is how many letters there are in T, how many distinct letters there are that we're going to have to meet requirements for. It's not saying there's only one of each. It's not saying if we find one and we need 3, we're going to be okay. No, we still have to find the amount that's needed, but this is how many overall requirements there are. So past that, we're going to say a resolution and a resolution length to compare things to. The resolution for now, we'll just set it, in case there's no resolution, we'll just set it equal to -1, -1. And I mean, it can be set to anything right here, honestly. And then we will set the resolution length, what we have to be, because we're trying to get a minimum, something smaller. We'll set it to infinity. Just to make things easy, any resolution we find should be better than infinity unless we do something crazy wrong. All right, and now we've got our setup. So that's awesome. We have our setup. Now it's time to just put it in play. But if you've gotten this far, the hard part's kind of done. We have the setup that we need. Everything else should kind of flow with each other. So we know we want to use pointers to go through here. That's how we're going to look and see what letters we have in the window. We've got our count T. We got to have a window. The left is set equal to 0, as is always the case in a sliding window. It's initially set up to equal to 0. And then we're going to have the right be set based on what character we are at that moment. So we're going to say for R, so for right pointer, in range, length of S, because we need to know the index of it, we're going to say character, so C, equals the string at index right. So that's the character we're working with. So what do we need to do with that character? Well, we have this empty window where we talked about how we were going to keep track of our characters. So we're going to say window at index C, and we're going to set it equal to, so that's that character index, just like we did up here with count T, 1 plus window.get, and we're getting C. If it's not there, we're getting 0. We're going to set 1 for it for the very first time because it's the first time we have in the window. And this is going to happen for every character, whether it's in T or not. We're not checking that at this point. We just want to know what's in this window. Let's add to it. That's all we're doing. Nice and easy, nice and simple. Okay, then we want to know, is it in count T or not? So we're going to say if C is in count T. So if that happens, great. It may be able to help us here. It may be something. But there's one more constraint or conditional that it needs to meet here. So if it's in count T, that's great. But unless the count at that index equals the count T count at that index, then it's not doing anything fully for us yet. It might be getting us closer to meeting the requirements, but it hasn't met them. This right here will have it meet the requirements. It'll also, if we get characters in count T and we've already met these requirements, it's not going to mess us up and say we've doubly met the requirements. None of that. It'll give us a little cushion, but this conditional is not going to come into play. But if it's something that's in count T and it's now caused us to meet a requirement from count T, so if it was our third A and we needed 3 A's, then we're going to come here and take that have variable and we're going to bump it up 1. So say our need is 7 and our have is 0. We've got have equals 1 now. We're another step closer to meeting all these requirements. So what would you do now? Well, we know how to log if we're getting closer to meeting the requirements, and we know how to log all the way up to meeting the requirements. So it would make sense to check, okay, we bumped our have up. Do we meet all the requirements now? Because at some point we're going to. So we'll say while have equals need. So that means we've found all the characters in T that we need, all the duplicates, the right amount of characters, whatever. We have them. So what did we say we wanted to do after we had them? Well, we want to, the very, very first thing, it's time to log a resolution. This may be the worst resolution that we have, especially the first one, but it's a resolution nonetheless. So we're going to say right minus left. So that's our index there. So, you know, if it's 0 through 9, so character 0 through character 9, then you're looking at the 9 minus 0 plus 1, because it's going to be 10 characters, and that's going to be, if it's less than our current resolution length, which resolution length right now is infinity, if it's less than that, we're going to, of course, set the resolution to left comma right, and we're going to set the resolution length to this updated number that we just calculated up here. We're going to say resolution length equals right minus left plus 1. All right, that makes perfect sense. So past that, we talked about it up here. We've met the requirement. We've logged a resolution. Now we want to see how much can we get away with. We want to see if we really need that character on the far left. Is it necessary? So we're going to say window string left. So originally that's going to be that string character 0, our index 0. Do we really need it? We're going to minus equal 1. So we're going to take away from it. We're going to say we don't want it anymore. And we're going to say if string index left is in count T, it may not even be in count T at all, but if it is in count T, then we got to do some thinking. And that's what, so like if it's in count T, that's one thing. But if we've decremented it now, and now it gets us where we're no longer hitting the requirements, that's a whole nother thing. So string index left and window string index left is now less than count T string index left. Then that's bumped us away where we no longer have the solution. So we'll take our have and we'll say have minus equals 1. We no longer meet the requirement for that particular letter. Regardless if we come to that point or not, we're going to bump the left by 1. And honestly, I'd like to have this up here just because it makes more sense. So we're going to come here, we're taking away from the windows, and we're bumping that left up by 1. So we're moving the left and shortening our window. Now, if that shortening of the window causes us not to meet the requirements anymore, so if we get rid of this A up here in this original example, you know, we have the A going through here to C. If that A causes us no longer to meet the requirements, well, we're back up here adding right characters. But if we're still able to meet the requirements without that left, then we're going to come up here and we're going to log this new resolution, this shorter resolution. We're going to log it in the shorter length. And we're going to come back down here and take another left character away and see if we can get away with it. And we're going to keep doing that as long as we can, as short as we can. And then once we can't anymore, once we no longer meet the requirements, then we'll start adding right characters again to try to get back to meeting the requirements and do the same song and dance over again. So once you've figured all that out and we've gone through that, all you have to do is get our left and right pointers from the resolution, pull them out, and just simply return the string from left through the right character. You want to have the right character, so you're going to say right plus 1. And here's what we need to put in here, this caveat. If resolution length does not equal float infinity. Because if it equals float infinity, then we never found a solution, and we don't return that -1 that we had up there, or whatever. Or, I mean, I don't know if we'd be returning anything. I don't know what happened on that. I haven't gone through it. But anyway, if it does not equal that float infinity, then we're just going to return an empty string. So this one, guys, not the simplest one ever. A little bit of convoluted code, but something that I think if you go through this problem a couple times and try to make a habit of seeing this and getting exposure to it, I don't think it's all that difficult. I really, really don't. I think there's far more difficult problems out there, and I don't even know if it really should be ranked hard on here, because I think once you figure it out conceptually and really know, like, okay, I'm going through here as long as it takes to meet my requirements. Once I've met those requirements, can I do better? What can I get away with to still meet those requirements? And you do that and do that and do that for as long as you can and update the results. But when you can no longer meet the requirements, then we start adding right letters again until we meet the requirements again. Then same song and dance, shade from the left, shade from the left. So you're adding right, adding right, adding right. I've hit it. Shade from the left, see if I can get away with it. Shade from the left, see if I can get away with it. Oh, I can't get away with it anymore. Add to the right, add to the right, and then start shaving the left again. So thanks for watching this one, guys. Again, I think this is one, if you drew in an interview, I think you could be kind of excited because it's a chance to show that you can do a harder level problem that I don't believe is all that difficult. So once again, thanks for watching. If you have an even simpler way of doing this one, or you think I've explained something, you have a better way of explaining it, or something that works for you better, please let me know, because I would love to hear it. I would love to potentially incorporate it. And just thanks again, guys. See ya.